Today we are going to be talking about relations and functions in Math 3. We need to start with a few definitions. So the first one is a relation is a set of ordered pairs. The next two we should know from all the way back in middle school, and that would be that the domain is the first element or the x values, and the range is the second element or the y values. Okay? And a relation can be represented in many different ways. A couple of the ways are going to be -1, 2 as an ordered pair, 0, -2, and 3, 3. If we were to put this in a table, the first column is our x values, the second column is our y values, and we have -1, 2, we have 0, -2, 3, 3. Honestly, you should already know this, but I'm still going to hit it quickly. Mapping, given our x and y values, it's going to go from the lowest number to the highest number. So our least x value is -1, then 0, then 3. For our y values, the lowest is -2, then 2, then 3. Mapping is the one that, as a student, I'd always forget, because it's hardly shown. It's easier, in my opinion, to do either a table or ordered pairs, or even a graph, than it is to do mapping. But mapping, you denote which x value goes to which y value by drawing arrows. Then for graphing, the points are already given. I'm going to go ahead and color them in. The next part of our notes wants us to state the domain and range of each of the relations shown. I'm not going to spend much time on this because, again, we should know how to do it. But the domain for the first one is the x values. I'm going to just drive this home one last time. 1, 2, 3, and 4. The ranges are y values. 3, 4, 3, 4. I want you to notice something. This last 3 and 4, it's obsolete. There's no reason to have it in this. We only need a 3 and a 4 one time. There's no point in listing it twice. So there's our range. Domain for the mapping, -1, 2, 3. Range 2, 4, 6. Domain for our graph here, we have 1, we have 2, we have 3, likewise for range. Alright, a function. This is a relation in which each element in the domain is paired with exactly one element in the range. To show you what that means, we do not want our x values to repeat. So we have a 0, we have a -2, we have a 4. 0, -2, 4, none of them are the same. So this is a function. If you look at t, we have 1, 2, and 1. We have 1 listed twice to 2 different y values. This is not a function. Okay? Alright, let's move on ahead. Consider each mapping. Is the relation a function? For the first one, look how this 8 here has 2 arrows to 3 and 2. That means it is not a function. And the second one, we have one line from 4, one line from 6, one line from -9, one line from 10. It is a function. Some of you may be thinking, but it has 2 arrows if you look at this 6 on the y. That's okay. Remember, it's not that every y has exactly one x value. It's just every x has a single y value, okay? Let's look at the tables here. We have -2s that repeat in this one. Not a function. We have no repeating x values in the second table, so it is a function. Consider a relation represented in graphical form. Suggestion. Write as a set of, and we're going to write it as ordered pairs. So, we have x value of 1 here, y value of 4. So 1, 4. We have an x value of 1, y value of -1. 1, -1. We have x value of 2, y value of 3. With those coordinates, we can see we have 1. This is 2. I apologize. We have 1 listed twice. One has a value of 4, one has a -1. This is not a function. You should know the vertical line test. You probably heard that term before. What you really need to know, if you draw a vertical line, it can pass through no more than 1 point. Sorry. 1 point of the graph so that the relation will be a function. Okay? So, to determine whether each is a function, I'm going to draw a line. There's only 1 dot per line. It is a function. The circle. Okay, I'm done. It touched 2 places here and here. Not a function. Absolute value function here. And I just gave it away by calling it a function, but if you, no matter where you draw the line, it'll only hit a point at 1 value. So this is a function. We're going to talk about function notation. Function notation is very easy. You're going to take the y and replace it with f of x. F of x is the function in terms of x. F of x is equal to 3x plus 1. You do that for the other two. I'm not taking the time to write it. The expression fx is read f of x. It represents the variable y. F3 represents the x value for the function f when x equals 3. Y'all, I apologize for that. Whenever I read this, I just read the 3. I didn't even see I was not thinking of the f. The f of 3 is the y value when x is 3. Alright. Let f of x equal 3x plus 1 and h of x squared plus 3x minus 6. Find the value for each of the following. F of negative 2. This is the f function. So we have f of x, or f of negative 2, is equal to 3x plus 1. We're going to plug in the negative 2 in for our x. So, f negative 2 is equal to 3 times negative 2 plus 1. F of negative 2 is equal to negative 6 plus 1, which is 5. Negative. Our point, the value, is negative 2, our x value, paired with our y value, negative 5. This is for the graph of f whenever x is equal to negative 2, y is negative 5. H of negative 3, using our h of x. And again, just to reiterate, whenever you have h of x, this is really just y. We're plugging in the negative 3 for anywhere we see the x value. So negative 3 squared plus 3 times negative 3 minus 6. Okay? If you do this, this is negative 3 times negative 3 is 9, plus negative 9 is 0, minus 6, so negative 6. X value, negative 3, y value, negative 6. You can use a graph of a function to find the points that are generated by the function. Okay? Go to the x value, go to the curve left or right. Since negative 3 comma negative 5 is a point on the graph of the function, f of x equals negative 5 when x equals negative 3. So, in other words, when x is negative 3, y is negative 5. That is quite literally all that is saying, okay? Now to show you in context of the problems here.
I'm not sure
Use
I
this.
understand.
Sorry. Use this graph of f of x equals 2x minus 1 to find these values. F of x whenever x is equal to negative 1. Whenever we have x of negative 1, we're going to go down. It's negative 3. At x of 1 is 1. And at 1/2, it's 0. These two lines here, I'm just showing you what the y value is, okay? I'm going to go ahead and take those off just to make sure it doesn't confuse you. We're going to use this absolute value of 5 minus x. X is equal to 2. We have a 3. When x is equal to 6, we have 1. And whenever x is equal to 0, we have 5. Alright. That is all that we are going to talk about today. Should be pretty easy.